Hello, and welcome to this Eureka Design Online webinar in association with Maxon. My name is Paul Fanning, and I'm editor of Eureka magazine. Today's presentation is called DC Drive Systems for Micro-E-Mobility, and we will be presented by Martin Leahy, sales engineer for Maxon. Now, before I hand over to Martin, I should just say that if you have any questions during the presentation, please type them into the box on the right-hand side of your screen, and we'll endeavour to answer them at the end. Any questions we don't have time to answer will be handed on to Maxon, and they'll be able to answer them offline. And with that, it just remains for me to hand over to Martin. Martin.
Thank you, Paul. As Paul mentioned, I work for Maxon UK and Ireland as a sales engineer, and today I'm here to present the webinar, DC Drive Systems for Micro-E-Mobility. So first, a little bit about Maxon. Maxon are a family-owned business since 1961. We have our headquarters in Switzerland. Over 3,000 people work for Maxon worldwide at 9 production sites, and we have subsidiaries in over 40 countries. So Maxon manufacture about 5 million motors per year in 16,000 different variations. Our technologies include, we have 5 winding technologies. We manufacture our own gearheads, sensors, and controllers. We have injection molding departments in the form of metal, ceramic, and plastic. And we also have a battery department, which I'll speak about a little bit later on. So at Maxon, we like to combine all our products into fully mechatronic drive systems where possible. In order to do this, we place a massive emphasis in research and development. Over 200 people work in the factory in R&D, and their duties are not only for continual product development, but also to work closely with our customers to realize their DC drive requirements. So what is micro-e-mobility? Well, it's kind of loosely defined, but typically it's for travel solutions for short distances, usually the first or last mile of a journey. These systems are usually less than 25 kilometers per hour. They employ an electric powertrain and have a payload capacity less than 500 kilos. Typical application examples include e-bike systems, electric scooters, trikes, segways. But at Maxon, we also include electric wheelchairs, rehabilitation vehicles, and mobility scooters into the overall mix. So drivers and barriers, I'm sure you're all well aware of some of these. With advances in healthcare, we have an aging population. And this population or cohort of people is going to look to keep their independence for as long as possible. And micro-e-mobility offers potential alternatives to traditional transport methods. The COVID-19 pandemic, we're all very sick of this, but it's led to a significant shift away from public transport. I read a recent Irish Independent article that said, although the traffic in Ireland is back to pre-pandemic levels, public transport is still down 50%. Micro-e-mobility could be perceived as potentially less risky as there's fewer contact points, and it's also easier to maintain your social distance. Urbanization, over 65% of the global population is set to move into cities and towns by the year 2040, and that's going to lead to an increase in demand for these micro-e-mobility systems. Environmental concerns, air pollution, carbon emissions, etc. Micro-e-mobility can be seen as relatively environmentally friendly. Flexibility, these systems are very compact, so parking isn't as much of an issue. And also you don't have to operate around bus timetables, flagging down taxis, etc. And finally, and it's very important, they're an affordable method of transport. You can purchase these systems for maybe less than €500 at the moment. And if you factor in your daily commute, you probably have a payback in less than 2 years. And it's also worth mentioning that these systems are good fun to travel on as well. Potential barriers include, regulation could be both a barrier and a driver. But in this case, because of the current lack of regulation, I'm including it as a barrier. Current infrastructure within our cities and towns are probably not up to spec to meet the demand for these systems. E-waste is probably a concern with the lower quality devices or systems. These systems mightn't be specified for outdoor use, etc. And they're being used outdoor, and sometimes the service life can be anything from 100 to 150 hours before they're making their way into our waste stream. Safety is obviously a concern, both operational and device safety. From an operational standpoint, it's obviously not as safe as being possibly in a car or a bus. So why DC drive systems? So the job of the DC drive is to convert electrical energy from the utility supply, which is essentially the battery, supply it to your electric motor, which in turn provides mechanical energy in the form of rotary motion. So DC drive systems offer the most efficient form of rotary motion when using battery devices. Their control characteristics are relatively simple, especially if you compare to AC. So the speed is directly proportional to the voltage, and the torque is directly proportional to the current. These systems offer a high starting torque, and when they're designed correctly, they're often very lightweight, maintenance-free, and resistant to vibrations, shocks, and extreme temperatures. So you've kind of began your project. There's a number of questions you're going to have to answer to your technical engineer or your motor provider. Some of these include: how fast does the load move? What are the max accelerations, the continuous and the max torque? The torque is essentially the twisting force, and it's measured in Newton meters. How long do the individual phases last? What are the usage demands? Are you going to be using it once daily, or are you going to be using it all the time? What environmental and ambient conditions will the motor work in? Will it be working outside? Will it be working in a hot environment, cold environment, etc.? And finally, it can't be avoided: what is the target market and the target price for your DC drive system? So let's take a closer look at the motors. There's two types of motors essentially used in electric scooters. You have brushed and brushless motors. Most quality e-mobility systems will use a brushless motor. This is a newer technology. It's also called a BLDC, or you might have heard of it as an EC, or an electronically commutated motor. These, as I mentioned, are a newer technology. They emerged around the 1970s. Brushless DC motors are said to be more efficient, have better power to weight ratio, they're more durable, they tend to run a little bit quieter, and they're less prone to overheating. But one of the major differences between the brushed and brushless motor is the service life. The service life of a brush motor is significantly shorter and dictated by the wear of the brushes. The brushes essentially wear down from friction, and this can cause voltage to act irregularly. But one of the major advantages that must be mentioned of the brush system is that it's significantly cheaper than the brushless system. So if you choose a brushless motor, these motors tend to like operating in thousands of, if not tens of thousands of RPM. So you might need a gearhead to both reduce the speed and multiply the torque. We'd recommend maybe a planetary gearhead, as this might be more efficient than a worm gearhead. But if you do decide, let's say, to go ahead with brush motors, you will be asked then, you might be asked to choose between graphite brushes or carbon brushes and precious metal brushes. We would suggest using graphite or carbon brushes, as these are kind of spec'd for both continuous and high currents, as well as start-stop operation. So if you take a look at the motor, you might have to choose between both an ironless and an iron core winding. Both systems offer benefits and drawbacks, but you should really consider ironless DC motors for more demanding applications. Again, they offer higher power to weight ratio, they offer more dynamic performance, and they're often said to be more efficient, which is a key selling point. So drive efficiency becomes very important, because the more efficient your system is, this is further compounded by the battery, which allows for more distance and less charging times. So if you're using a brushless motor, you're going to need a controller. Whether this controller is integrated or not might depend a lot on your IP protection. IP protection is essentially your device's ability to withstand dusts and solid. So most micro e-mobility systems have an IP54 protection level. So the 5 stands for the dust or particle resistance. So in this case, it's dirt, dust, oil, and other non-corrosive material protection. And the 4 stands for water or liquid protection, which in this case is splashing water. So it's worth bearing in mind with an IP54 protection. If you decide to go home and power wash your system, your system is liable to get damaged here in this scenario. So battery requirements for e-mobility. Maxon began their battery journey through the e-bike system. We had a good bit of difficulty with the supply of batteries, and we decided to go about manufacturing our own batteries. Of course, this is not a very easy task because you don't only need very specialized equipment, but you also need a great deal of technical expertise. So the golden rule of battery systems is to lower the size, the weight, the charging time, and the price of batteries, whilst also increasing their safety. Again, a number of questions you're going to be asked is the capacity of the battery, the voltage, the continuous current, the max current and duration, possible charging times, and the number of cycles required, i.e. the service life. So your battery system is finished once all your cells are professionally glued and wired together. You're also going to need a battery management system, or a BMS. The BMS essentially supervises the battery, the charging and the discharging procedures, whilst also avoiding overcurrent, surcharging, depth discharge, and too high temperatures. And the BMS will also provide communication with your host system. So again, I mentioned earlier, Maxon like to combine all our products into fully mechatronic drive systems. So initially, when we begin a project, we'll suggest using the standard catalog components, and there's possibly a number of reasons for this. One of them is obviously the lower cost, and then obviously the quicker turnaround. So you get to test the technology quicker than waiting for a semi-customized product. So once the standard components fulfill their duty, we move on into semi-customized products. And then the final system is the fully customized bespoke system that is essentially tailor-made for the customer's needs. This is kind of seen here with our bike drive air system. So this initially started out using an EC motor and also a single stage planetary gear set. And then it's developed into this bike drive air system over time. So you can see this again, we like to use all our block sets, electronics, motors, gears, and batteries, and then eventually come up with the bespoke tailor-made system, which you can also see on your right. So I mentioned the bike drive air a couple of times. E-bikes are conquering cities, towns, rural areas, and mountains. And Maxon began this journey looking at existing systems, which provide powerful support, but maybe are a bit too heavy and sluggish to handle. So Maxon wanted to kind of set about changing this. And with the bike drive air, Maxon developed an invisible e-bike system that weighs only 3.5 kilos, and this includes the battery as well, and it can be integrated into very elegant frames like racing frames, gravel frames, urban, kids, and even mountain bikes as well. So again, the bike drive air kind of represents 60 years of experience in the development and production of electric motors, gearheads, and electronics. And again, its centerpiece is a mid-mounted e-bike motor that provides riders with both a natural cycling experience and very agile handling. And the secret behind this is there's a unique freewheel technology. So support is only given to the rider where necessary. So it's a very natural experience, and it also almost feels like riding a tailwind. Moving on to another project, the Scalevo Wheelchair. So this is a wheelchair that can improve the lives of disabled people and give them the mobility they deserve. So this project was run out of a university in Zurich. The students applied through the Young Engineering Program, or YEP program, and this essentially allows for discounted drives, a good bit of technical expertise, as well as marketing on all Maxon channels. So the Scalevo Wheelchair combines kind of two well-known systems into one quite spectacular device. Rubber tracks offer optimal grip on very difficult terrain, and sturdy wheels grant mobility and freedom on flat ground. So on flat ground, the wheelchair balances on the two large wheels, and these allow the chair to turn on the spot and move through very tight spaces. And then on stairs, the two tracks fold out and they adjust to the angle of the stairs. The track material was specifically built for use on stairs and offers excellent grip for safety. And when the wheelchair reaches the top of the stairs, the two wheels you can see in the first picture there slide out, and they prevent the wheelchair from falling over. So again, the drive of the Scalevo wheelchair consists of brushless DC motors from Maxon with a diameter of 60 millimeters. These are connected with GP52 planetary gearheads, which also contain ceramic components for additional life and additional torque as well. So this modification obviously gives the wheelchair user additional service life. The Maxon controllers are also used. In this case, it's a positioning controller. It's a very fast and precise digital positioning controller that is suited for use in brushed and brushless motors. And again, the entire weight of the drive system was 3.2 kilograms. So finally, some useful Maxon resources if you're going about developing a micro e-mobility system. The first of which I'll mention is the catalog. So the catalog not only contains all our components and products, but it also contains a good bit of technical expertise or technical information at the beginning of the catalog. The next we have Erskafarder's book, The Selection of High Precision Microdrives, which is available for purchase off the website. Our Formulae handbook are downloadable for free, and you can also get a hardback copy posted out to you for free as well, and they're available off the website. We have a significant resource section on the website, and the Maxon Academy provide a number of video tutorials that are very useful. We have our Driven magazine, which is released quarterly, and this not only contains a good bit of technical information, but it also contains a good few case studies that you could potentially draw inspiration for. And finally, I mentioned the Young Engineering Program. This is really worth pursuing if you're a student or a startup. Again, it's available from the website. It literally takes 2 minutes to fill out a form, and basically you'll hear back from Maxon whether in 1 to 2 days whether you've been successful. So thank you very much. I look forward to hearing some questions from you. Back to you, Paul, I guess.
Yeah, absolutely. Thanks very much, Martin, for that. We do have some questions. Let me start with this one. Should micromobility users be subject to the same level of stringent safety criteria as cars, i.e. crash tests, checkpoints for sobriety, tyre tread depth, working indicators, etc.?
Yes, I believe so. I think if we want to incentivize these systems into wider spread use, they have to be subjected to the same safety criteria as other road users, in this case, cars, buses, etc. So it might be very unpalatable for many, and it might even be a potential barrier, but I think essentially they're critical. These policies are critical to ensure everybody's, kind of driving or working off the same plan. And I would consider them very necessary in order for longer term use of these products and systems.
Okay, thank you. Next one, how much emphasis does Maxon put on mobility solutions compared to its work in medical, industrial, automation, etc.?
Yeah, we have a number of business units. So in total, we have 4 with maybe the potential of another one down the line in terms of agriculture. But for the time being, we have 4, and they're medical, aerospace, industrial automation, and mobility solutions. So the idea of the different business units is to concentrate all the expertise under one roof. So in terms of mobility solutions, this might include AGVs, automated guided vehicles, AMRs, etc. But it definitely includes the e-bike and other mobility solutions as well. So we place a massive emphasis in mobility solutions, and that's evident from them having their own particular business unit.
Okay. The next one is on the right to repair. Should I be able to repair my own scooter if necessary?
Yeah, this is kind of tricky, I guess, from an electrical standpoint. Maybe you should go back to your provider, etc. But in terms of repairing wheels and kind of the mechanical components, yes, you should be able to repair them. But if you're kind of accessing, especially with the systems that are higher end premium, and they might have a very to achieve a high IP protection, they might be in quite enclosed, etc. So not always going to be possible, I think. And I think not everybody should be repairing or messing around with batteries, etc. Unless they are, they're educated to do so, essentially.
Okay. And one final one. What is a Pedelec, and do I have to pedal when I cycle an e-bike?
Yeah, a Pedelec is essentially the very same as the Bike Drive Air in terms of you do have to pedal to get the output. So it's not a case of throttling your bike and off you go. It's an assistive bike. And what's kind of interesting about Pedelecs is they fall under the same regulation as normal bicycles. So they, in terms of, they're easier to use, let's say, in cities and towns, etc., because they're regulated to do so.
Okay. And that, as I said, that is the last time we have time for. But as I said earlier, if there are any other questions that we haven't had time to answer, we will pass them on to Maxon and they will answer them for you offline. And with that, it just remains for me to thank Martin for the presentation today and to thank you all for joining us. Thank you very much.
Thanks, Paul.